Hello and welcome to part 5 of our lecture on flow control statements. So far we have looked at different flow control structures. We've looked at the if-else statement, the switch case statement. We've looked at several looping constructs that we have: the for loop, the enhanced for loop, the while loop, and the do while loop. Now it's time for us to do some more stuff with those loops by putting loops inside loops, and that is what we refer to as nested loops. There are several situations that might require you to put a loop inside a loop to better address your business requirement, and that's what we are going to be looking at throughout this video. And towards the end of the video, we are also going to look at the continue and break keywords that we saw in the earlier parts of this tutorial, and we're going to see how you could use that to improve flow control. So with that said, let's look at something here. I have a chart on the screen here. The first one here, you have numbers like 1, then you move to the next row, 1, 2, the next row, 1, 2, 3, the next row, 1, 2, 3, 4, and it continues like that. And you have the same thing done but with asterisks this time, and you have another triangle printed here, and then you have maybe the Pascal's triangle. Now, to address a situation like this, one of the easiest way for you to go about it would be to use nested loops, and we're going to implement that and see exactly how they work together. Like I said, nested loops simply means putting loops inside of loops, like putting a loop inside a loop. It could be a while loop inside a do while loop. It could be a for loop inside a while loop. It does not matter which one. You just use the one you're most comfortable with. So with that said, let's go to example and bring up our NetBeans and actually write the code so we see it in action instead of just talking about it. So I'll create a method here, public void do nested looping, and that will be the body of my method down here. And inside here, I'll create a for loop. I'll just write out something, then I'll explain to you. So I'll say for int x is equal to 1, x is less than or equal to rows. Okay, now I'll declare a variable of your first int rows to hold the number of rows we want in whatever we're trying to print out. Maybe our triangle we want to print out, and I'll say x plus plus. And then down here, it does not make too much sense right now, don't worry, I'll explain it to you shortly. I'll say for int y is equal to 1, y is less than or equal to x, and I'll say y plus plus. This is not correct, it's not space here. Alright, and I'll do that. Good. I'll say system.out.print, not print, and I would print out the value of y, and I'll just add some space to it so that it looks a little more presentable. Then down here, after that loop finishes, I would move on to the next line before I start printing again. Now let's see, but let me run it to be sure that we have our output correctly, and then I'll explain to you exactly what's happening there. Oops, I'm not calling it. So here I would say Java tutorials JT is equal to new Java tutorials, and I'll say JT dot do nested looping, and I'll take this off. This is not part of this video. That was what we saw earlier, so don't look at it and get confused. And I'm going to run this. Alright, we have the structure we wanted there. So let's see how that comes about. Alright, so what do? I start by declaring a variable, rows. You could be taking, when we start reading from the console, it would be a good idea to ask the user to put in whatever number of rows they want, and then we print out something nice, or maybe do something depending on what you want. It's logical that when people interact with programs, they put in their own data. But for now, we're going to type everything directly into our code, and later on when we talk about I/O, we're going to see how to get input from a user or from some other source, maybe from a file. So I declared the number of rows I want. I could change it to 5 rows, 10 rows, 100 rows. It doesn't matter, it's going to work just fine. And then what I do here is I say int x is equal to 1. So I'm declaring a variable. I'm saying start from 1. Now I'm using this for loop here, the outer loop here, to count the number of rows. And I'm using this one here for the number of columns to print. So I know that for the first row, I'm going to print 1 column. For the second row, I'm going to print 2 columns. For the third row, 3 columns. Fourth row, 4 columns. Fifth row, 5 columns. And it continues like that. Alright. So what do? I say for the first row, I know that this for loop here is going to keep count of the rows. The outer for loop that I have here is going to keep count of my rows, and the inner one is going to keep count of the columns. So every time the first for loop, when it executes for the first time, I know that it has finished. What do? I need to print a blank line by using the println method so that it moves to the next row. But before printing the blank line, what do? I print the current row with all its columns. So when I start here, x is equal to 1. It means I am on row 1. So what do? How many values do I need to print on row 1? It's the first row, so it's supposed to be 1. And since the row is always equal to the number of the row number is always equal to the number of items to be printed, the number of columns to be printed for that row. Alright, so since the number of columns to be printed for each row is always equal to the number of rows, we can rightly loop through these x times for every given column. So if we are on column 1, if we are on row 1, we'll go through it 1 time. We'll go through the inner loop 1 time because we need just 1 value. If we are on column 2, we'll go through the inner. If we're on row 2, sorry, let me start this all over. If we are on row 1, then we'll go through the column, this inner loop 1 time because we only need 1 value. If we are on row 2, we'll go through the inner loop twice because we need 2 values. If we are on row 4, when x is equal to 4, then we'll go through this inner loop 4 times as well. And that's why in my condition here, I'm always making sure that y is less than or equal to the value of x, and then I increment y later on and test again. So let's run that again, and that's what we have there. What's happening is, for the first time, x is 1, right? Good. Is 1 less than or equal to 10, which is our number of rows? That's true. So we get into this loop. But now we don't print anything yet. We know that we are on the first row, but now we need to start printing the individual column values. So what happens? We declare a variable y, and we initialize it to 1. And then we test, is 1 less than or equal to the value of x? Obviously, 1 is less than or equal to x, which is 1. And then we go into the loop and we print the value of y, which is 1. And then we increment and y becomes 2. Now we loop again. We increment the value of y, it becomes 2. We do the test condition. We don't loop. We do the test condition here. And now is 2 less than or equal to x? That is false. So at that point, this loop here finishes, and we print out a new line, which means we go to the next row, and then we come to this other part, x plus plus. What happens here? We increment x by 1. X becomes 2, right? Now, is 2 less than or equal to the number of rows, which is 10? That's correct. So we go back inside here. This for loop starts all over. We reinitialize y to 1. Is 1 less than or equal to the value of x, which is 2? Yes, that is correct. so we print 1, and then we go to the increment section, and then we go to the increment section of the reinitialization section of this inner for loop, and then what do we do here? We say y plus plus, and now y becomes 2. Is 2. We come back now to the expression, the test expression, and we say is 2 less than or equal to the value of x, which is 2? We say yes, and what happens? It prints 2, and then we go back to reinitialization, y plus plus, y is 3, and then we test again. Is y less than or equals to x, which is 2? That is false, because y 3 is not less than or equal to 2. 3 is greater than 2. So we no longer execute the loop, but it jumps to this point and prints a new line, shifting us to the next row, and then it hits this, and then it goes back to reinitialization of the outer for loop. And now x becomes 3, and then we test the procedure again. Is 3 less than or equal to number of rows, which is 10? That's true, and then it goes back inside here, and we keep on repeating and repeating until everything prints out correctly. And then at the end, when this value becomes greater than 10, the loop ends and we get out of it. Now, there are two other statements I want you to take good note of. I'm going to take out this for loop here first, and I'm going to explain that simply with this. Let's make a method. Let's write this method to print out the value of x every time we loop. So I'll just print out the value of x here, and let me run this. I expect this to print from 1 to 10. Alright, I have it printing out from 1 to 10 correctly. But sometimes you might want it to stop at a certain point. Let's say I got a value, but maybe I was using some value for comparison. Or let's say, let me put it this way to make it simple. Let's say I want it to stop at a certain point. For example, if there was a value somewhere, when it got to 5, maybe I wanted it to stop. So what I could do inside here is, I could say, if x is equal to 5, then what I'll do is, I'll break. Remember, if you have just one statement for an if block or a loop or whatever, then you don't need the curly braces. So I could still take this off, and I'll leave it like that, because this if statement here only controls this block, this break here, this break that we have here. So what happens? Now look at what's going to happen here. When I say 4 int x is equal to 1, x is less than rows, what's going to happen? X is equal to 1. It's 1 less than the number of rows. Fine, that's true. But it's 1 less than the number of rows. Yes, so I get into the loop and I start executing the loop. While I'm executing this loop, you realize that I have another test here. I say if x is equal to 5, break. What's going to happen here is, this loop is going to keep on executing. For the first time, when x is equal to 1, it's going to do this test, and it's going to see that 1 is not equal to 5. So it will not execute this, and it will come down and print this. I'll continue here, and I'll say x plus plus, x becomes 2, it tests, and then this fails, so it will not execute this, and it continues printing until when x is equal to 5. As soon as x equals 5, this statement will be hit, break. And immediately break is hit in a loop, it stops the loop immediately, which means when this statement here evaluates to true, the loop is going to stop automatically and it will not continue, which means it will not even come back to initialization, it will not even test again. Once you hit a break statement, it stops automatically. Your loop stops there and it no longer executes, and your code simply continues from down here. System.out.println, the loop just ended. Alright, so let's run that and see what's going to happen. First of all, I'm going to take this out and then we'll run it. You see it printing from 1 to 10, and maybe I should add a new line here. You see it printing from 1 to 10 and then saying the loop is ended. But now when I add this statement and I run it again, you see it only prints from 1 to 4. Are you seeing that? It only prints from 1 to 4 and then it stops. At this point, x is equal to 5, but you never see the point where x is equal to 5, because immediately after this statement, the loop, we got out of the loop and we never printed 5. But if we put this here, probably we should do this so that you see it clearly. If we put this here, what's going to happen? It's going to first of all print the value of 5 to show you that it actually gets into the loop, but it breaks only after this statement. So you're actually going to see, let's look at the output that we had earlier. You see that when it was down here, when we had it like this, when we had the code like this, that's what we get. You see, we are inside the loop when x is equal to 5. We get into the loop, but what happens? It breaks before ever getting to the point where it has to print the value of x. And the same thing, let's see how it's going to work now if we copy this and paste it up here instead. And if we run it again, now you see that it prints 5 and then it breaks the loop. So every time your program hits a loop, a break statement within a loop, it breaks the loop automatically. Now, I'm going to change this to continue. And let's see what the continue keyword does. Let me put this here. Now, every time you write a piece of code, for example, let's say I wanted to print out the numbers from 1 to 10, but I don't want the number 5. So what I'll do here is, I'll start printing the numbers. I go through the loop as usual. But when I get to the number 5, I tell the loop to continue. Once you hit continue, unlike the break statement that stops the loop automatically, when you use continue, when your program hits continue, it stops the current execution of the loop. Like, it does not break the entire loop, but stops just the current execution and jumps back to reinitialization. So when I start looping, when it gets to the point where x is equal to 5, what's going to happen is immediately it hits this statement. Instead of coming here and continue printing or breaking out of the loop as the break statement does, once I hit continue, it will no longer print these remaining statements here, but it will jump directly to reinitialization and x will become 6. And then we continue looping. So let me run that again. And you see that I have all the numbers printed out except 5. Why? Because immediately it hit continue, it did not come down here. It jumped up back to this place, and that's why we could continue from 6 going 7, 8. Oh, to illustrate this more, a good way will be to, let's make row 100 and let's print out all the even numbers from 1 to 100. All the even numbers between 1 and 100. So I would say if x mod 2 is not equal to 0, then we know that it's an even number. If we divide something by 2 and we have a remainder, if the remainder is not 0, then we know it's an odd number. If the remainder is 0, it's an even number. So if it's an odd number, we want to continue. So if it's not an even number, which means the remainder is not 0, then we have an odd number. So we continue until we get to the end, and we only print out even numbers. So if I run this again, now you see 2, 4, 6, 8, 10, 12, 14, 16, right up to 100. And it's that simple. So you see that every time you hit continue, the current execution of the loop is stopped and it jumps to initialization and starts the next execution of the loop. But once you hit break, if I change this to break, for example, then our loop is certainly never going to print anything even. You see, nothing here from within the loop. Good. I'm sure that is pretty straightforward. And one last thing I want to show you is using the break statement with nested loops. So I would put back my initial for loop that I had here. Int y is equal to 1, y is less than or equal to x, y plus plus, and inside here I'm gonna have my system.out.println, print, and I want to print out the value of y and maybe just append some empty strings so that the presentation is good. I'll take this out and I'll print out an empty line down here so that we move on to the next row. Alright, now let's run this to be sure that we have, ouch, that's just too many numbers. I'll take it down to 10. Alright, we have the initial triangle we had before, but what I want to do is I want to show you how the continuous statement, let me start with the break statement, how the break statement works with nested loops. And this is how it goes. So what I'll do is inside here I'm going to put a break. We'll start with break and then we'll go to continue. I'll put break. No, not there. I'll break every time alright, so I'll say if y is equal to 4, what I want to do is I want to break. Let me put this so that we actually see exactly where it starts and ends. What I'm doing is it's going to print out this same triangle that we have here, but it's going to exclude 4. Every time we see a 4, it's going to break out of this loop, but we are going to see it continuing until we have all the 10 rows. So let me run this again and let's see what we have. Good. Are you seeing? It starts printing, but every time we get to 4, like we start the first row, right? It prints fine. Second row, it prints fine. Third row, it prints fine. But every time a row gets to 4, we break. And when we break out of that, you see that we are breaking out of the inner loop, the one that is printing the columns out, not the outer loop. It continues again. Like for example, when x is equal to 3, no, when x is equal to 4, we test is 4 less than 10. That is true, and we get into this inner loop. And what do we do down here? We say y is equal to 1. That's fine. We test is 1 less than or equal to x, which is 4. X is 4. That says true. And then what happens? We go inside there, we test. If y is equal to 4, we want to break out of the loop, right? So every time it executes and it gets right up to 4, what happens? It breaks this loop, but you will see that the outer loop continues. That's why we have systems that where we have this one printing a new line and then it continues again from the outer loop, and it keeps on doing that over and over and over. But you see that every time you hit break, it does not stop all the loops. It stops only the loop in which it is found. The break statement stops only its containing loop. It does not stop the parent loop of its containing loop. Now let's see the continuous statement. In this case, it's going to print out the values. It's going to continue printing out the other values, but every time it gets to 4, it's just going to skip 4, as if 4 did not exist. So now if we look at our triangle again, you see that you have all the values printed out except 4. And like I said with the break statement, it breaks the current, it breaks execution of the containing loop, not the outer loop. Same thing, the continuous statement stops the current execution of the containing loop. Just the current execution, not the entire loop. All the other executions will continue without any problem, except for the current one. Like it says continue, just stop this one and continue from the initialization section. All right. Now that we know how these work, I want to show you one more thing. You're not compelled to nest just 4 loops. We could decide to do this with a while loop. I'll say int y is equal to 1 while y is less than or equal to x. And I'm going to come inside here. I'm going to say system.out.print print, and I'll say y plus some empty space. And remember, the while loop does not have a reinitialization of its own, so I need to put some condition that will break my loop at some point. That's why I put a y plus plus here, and then I put out my statement here that will move us onto the next row. .out.println. And if I run these again, we expect to get the same output as we had earlier. And you can do the same things with the break statements that we had before, or the continuous statements that we had before. So that's said about loops. I'm sure we all understand exactly how they work, and it's pretty straightforward. I recommend, like the figures I showed you, try printing them out. You might add some more substance to it. Print the Christmas tree, print the Pascal triangle, just print anything. Play around with the loops, play with them as much as you want. But I want to warn you about one thing. It's good to use loops. They are a very good feature of programming. They're going to help you a lot, but don't overuse them. Why do I say don't overuse them? Because what I realized, in my programming career, what I've realized is when I find myself nesting loops. First of all, when you nest loops, you agree with me that you increase the complexity of your program, and your program is a lot more slower. Like it has to execute something over and over and over. It's repetition, so it's obviously going to be slower. So once you find yourself nesting loops all the time, you probably want to think again, because I can assure you, like 80% of the time, you're going to have some mathematical expression or some better way of presenting it. You're going to have some mathematical expression that will help you reduce the complexity of your program. And you want to be very careful with that. Use them, but like I said, don't exaggerate. When you find yourself using too many loops, think around the situation again, and I can assure you there's some structure, there's some expression that can help you simplify the operation instead of using many loops. Because, I mean, if you have a program that works but it's too slow, nobody's going to use it. I don't want to click and wait for 5 minutes for something to happen, or wait for 2 minutes, wait for a minute. Waiting for a minute in front of your computer for something to happen, it's too much time. 30 seconds even. So you want to watch out the way you use the loops, but practice with them, play around with them to get a good mastery. And then when you master them so well, you can start seeing how you can control the use of them in your real programs. All right, thank you for listening to this. And in the next tutorial, we're going to start talking about some different kinds of data structures that we have. We're going to start talking about arrays, and I'll see you then.